Hello! We are in section 4, and this time we have to tackle the last lesson of the section. As always, the last lesson is dedicated to apply what we have learned throughout the whole section. In this occasion, we will see a small introduction in which we will approach a particular problem of what we have studied until now, and then we will see an example that will reflect some of the aspects that we have treated throughout this section. Well, on this occasion, Jay asks, we know that a ray strikes a sheet, and we have studied what happens when it passes through an interface between two media. But what happens if instead of a single interface, it passes through two and returns a similar medium? Okay, so what we're going to do is apply the concepts we've seen in the law of refraction when we studied the refraction to see if we can answer the questions from Jay. We will apply Snell's law to the first interface that showed us the relationship that existed between the incidence angle and the refracted angle, with the refractive indices between the incident and refracted media. Okay, if we take that into account, we calculate, taking into account that the angle of incidence at the second interface is going to be equal to the refracted angle at the first interface, R, we finally get a relationship between the angle of incidence I, which is the incident angle, at the first interface with the angle of incidence I prime, which is the angle of incidence at the second interface, or the refracted angle at the first interface. Well, if we now want to know the angle of refraction R prime, which is the angle at which the incident ray exits, what we will have to do will be to apply Snell's law again, but now to the second interface. Therefore, we will have a relationship between the incident angle and the refracted angle at this second interface, and the refractive indices at the same. On this occasion, in order to differentiate them from the previous one, we have denoted them with the letters, but with a prima. If we take into account what we had obtained for interface 1, we substitute in this expression, and therefore we obtain that for plane parallel sheets, the angle of refraction through the second interface is equal to the angle of incidence. Well, now what Amanda is asking us is what deflection the beam or a beam will suffer when it is incident on a parallel plane sheet. Amanda encounters a quartz film and she has several questions. Let's see. Amanda has a quartz sheet, as we have said. It is located in the air. This sheet has flat and parallel faces with a thickness of 14 centimeters and a refractive index of 1.54. A ray is incident at an angle of 60 degrees with the upper face of the glass, and what she wants to know is the angle inside the quartz and the emerging angle with respect to the perpendicular to the sheet. You also want to know the lateral displacement of the beam as it passes through the quartz. Here we go. The first thing we have to take into account to determine the angle inside the quartz is which value the incident angle has. Well, at the bottom of the slide, we have the data proposed for this problem. We have the thickness, the refractive indices, and we don't have the angle of incidence, because what we really have is the angle that the beam forms with the sheet. The angle of incidence is the angle formed by the incident ray with the normal to the surface at the point of contact, and therefore the angle of incidence is 30 degrees. It must be taken into account that the refractive index of air is not exactly 1, but 1.0003, as indicated by the transparency. Anyway, for the problem we are going to deal with, we can consider or we can approximate this value to 1. Well, let's continue. We are going to use Snell's law. We obtain that the sine of the refracted angle is going to be equal to the quotient between the refractive indices in medium 1 and 2 by the sine of the incident angle. If we substitute values, we obtain that the refracted angle is 18.97 degrees, the angle that the ray experiences in the interior of the quartz. Then it is the refracted angle at the first interface. The angle at which it exits at the second interface, as we saw in the introduction, coincides with the angle of incidence and is therefore 30 degrees. Well, now what we want to know is the lateral displacement of the beam as it passes through the quartz. As it can be seen in the drawing, the incident angle has a deviation with respect to the refracted angle through the second sheet. It is parallel since the incident and refracted angles in the last sheet are equal, but nevertheless suffers a small displacement. And that is precisely what we want to determine. To do this, we will determine how much is the distance AC. From the cosine of the refracted angle, it will be equal to a B, which is marked in yellow, divided by a C, which will be the hypotenuse. Therefore, AC will be a B divided by the cosine of the refracted angle. And substituting values, we obtain the value of that distance, which is 14.8 centimeters. Well, to determine the deviation, we have to take into account the angle beta. Which value will the angle beta have? Well, the angle beta will be the angle of incidence. Since this angle right here has to be equal to this one here, to all of this one, and therefore beta will be 30 minus the angle of refraction that we had obtained, which was 18.97. The sine of beta will be equal to that deviation, divided by AC, which we have just determined, and so we get that the deviation is 2.83 centimeters. Well, what have we seen throughout this lesson? We've done a little introduction by seeing that when we have a flat parallel sheet plate, the angle of incidence in the first plate and the refracted angle in the second plate are equal. In other words, the beam only undergoes a small displacement. And finally, we have calculated the displacement experienced by the beam. That's all. See you in the next section.